Okay, I'm back again this time, and I'm going to switch to desktop. What we all missed was a problem solution to Visual Studio Code that I was having. Let me just make this blank. So the issue was when I plugged everything in, this particular import board wasn't working properly. It was, I don't know what was going wrong. So what I decided to do is go back because there's a set of scripts in the extension CircuitPython for Visual Studio Code to build the stubs. And that's what I did. So I created a directory to work in, Mr. Problem. Yes, and I'm still recording. And I use git control R G I D control R doink 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 to do this. Basically, to go get his extension. And then in his extension, there's a scripts directory. So we go into the scripts directory and ignoring the 3 subdirectories that are there because I created them already, we have a look at that shell script. This one right here, build stubs.sh. This is what's in it. Now, the biggest problem I had with it, insert. No, we're in less. Let's go, not be in less. Let's be in Vim. We need a real thing. And get this. Okay, it looked like this. So what I found is, first of all, after you get done all this steps, which all work, right? He backs up one subdirectory out of CircuitPython into scripts, and then this doesn't exist. This actually exists 2 subdirectories back. Okay, not good idea. So this guy here that builds stubs py is in that directory, the scripts directory, but it wasn't working properly. And then he removed this. And what this ended up doing, the remove stubs/board, it removed a couple of key parts, which I don't know why he was doing. So what I did is I followed all the steps up to the point. I moved the stubs directory back. And then I control R. I did a Python that, basically. So I bypassed his stuff. The other requirements one is simply one more module that you really doesn't seem to make much of a difference. It was installed. That generated boards. And when you look at all this, if you look at stubs, there's a board directory that somehow he'll remove. Don't know why. And in boards, there's this guy right here. Now this guy is the generic board Python import file. And all these guys here are all the vendor IDs. And in it, you'll find all the product IDs under those vendors. And then you'll find all the data for all the pinouts on all the boards. Okay. So then I moved all those. If we go back here, we go into your VS Code. This is the hidden directory, extensions, Joe, like so. And what I did is I moved his boards.org and his stubs.org out of the way. And I put those new directories in there without removing those board and board subdirectories out of there. When I come back to CircuitPython, after reloading and everything, usually if you do messing around this, just reload Visual Studio Code so that it kind of understands the environment change. But now if I put my cursor on here, things start to work a little better. Now, I did find out one other thing you had to do. In your settings.json, you need to add a couple of paths more. There wasn't already enough. I had to add these guys in, but I found out that even though the forums say that in this file, this is supposed to be anything trailing into the CircuitPy directory, so that includes the lib folder, doesn't work. If I didn't put an extra line in there with lib, it didn't work. The other one I had to add in, not just the stubs thing over here, I had to add the boards one also into it. And then in the master workspace file, this one here, you get this effect here that helped. Notice this. I probably could have gotten away with just boards, but this specifically finds this board that I'm working on. That's what this is. This 239A vendor ID is actually belongs to Adafruit, and 8021 is the Metro board. Another thing I found out, don't turn this on. If you do that, you'll fill your drive up and blah, 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 blah. That led to a final little thing that you have to clean up sometimes. And you notice these dot trashes, dot metadata, dot system volume, the file system, vents, SD. Some of these belong to Mac, some belong to Windows, and some belong to Linux. And as you can guess, the dot trashes belongs to Linux. Okay? And if you right click a file in here and you say delete, it gets put in this trash can. It's actually not deleted. Best thing to do is come back out to your file explorer, the trash can, right click, empty trash. The other thing too, if you're deleting files in your file explorer, you know, you're here like this and you want to delete this file, turn on this option where the actual real delete exists, not move to trash. If I could, I would remove it from Dolphin. I'd take move from trash out completely. It just sucks to have it. You get this trash can that slowly starts filling up, including in here, and space is precious on these controllers. Like, so. But that fixed this. This allows for this to be working. Now, in the code in here, what I was doing, I have, let's go back to the actual code scene. So you can see I have this board and I've been working on it. Now, up to this point, let me scroll down. So I've remmed out a huge block of code. So up here in this green here, I was cycling through all the bits. So basically first bit, second bit, third bit, and the row. And this is what it maps out to up here, this stuff right here. So Arduino states that when you're writing to these shift registers, you're actually writing this bit 0, then bit 2, then bit 1, then bit 3. Okay, so 3 being the rows. Okay, so that it really says, instead of red, green, blue, it's actually red, blue, green. Right? So this last one, the actual rows here, row 1 is actually, if you set this to 1, you get row 1. If you set this to 2, you get row 2. If you set this to 4 factors of 2, you get row 3. If you add them together, you'll get those rows. So if I add 4 plus 2 plus 1, 7, I'll get the first 3 rows on this panel. So now what I was working on here was I cloned the whole thing. And what I want to do is preset some of the stuff in here. So what we have here, we have a problem in my code. It just says function requires a lock. Okay, so what they're really getting at here is for some reason I've lost my lock. So let me find what I've done. I've remmed out something that I shouldn't have remmed out. Okay, so the problem here is I'm on the wrong idents, I think. We're checking here for the lock, SPI unlock, SPI try lock. So if else 4. So I think this is wrong. To me, this should be like this. We should be one indent in. I hate this when it does this. I really, really do. True baud rate. We're setting the parameters. So why are those idents good and these ones not good? Fucking idents. It's just like annoying. I need a copy of this file. Let's go make I need a backup of this. And we'll just call code bak1.py. And out of here, I need a copy of all this. Control A, Control C, Control V, Control S. Go away. Come here and let us chop all this out. And let's chop all this out. Whoops. Oh, my idents are solved because the damn block comment's not there anymore. What the bloody hell? Hi, I'm the print statement, and I don't have an ident. Comment out. Yeah, sometimes this linter doesn't do stuff correctly. So all I'm doing right now is cycling through, looks like one color. And output. No, tasks. Can we go back to this? Ooh. Where is my terminal? Terminal. There we go. So what we're doing is bit 3. No, bit 1. Bit 2 and bit 3 are 0. So let's correct our debug a little bit here. Comma. I don't know if I can do that. Yeah, I can. There we go. So basically what I've done is I've eliminated 2 of the loops so I can control the very first one. So I'm cycling through all the way in factors of 2. Now, what I'm going to do is we're going to change the for loop slightly. And we're going to rim out that for loop in a sec here. For bit 1 in range 255 and home. Oops. Oh, we need a colon. Yes, I know, colon. So, okay, for bit 1 in range 255. Is that good enough for the loop? Something like that, it should work. Control C, Control D. It doesn't like value must fit into 1 bytes. Let's try 254, Control S. No, take that out, Control S. There we go. So what we're seeing here, and this is, you can't really see this. You know, I really, really need a frickin' diffuser to show this off. Anything. What can I use? It is so frickin' bright. What if I go to 3.3 volts instead of 5 volts? That helps. But this, I can see it, but it's so fucking bright for the camera. Why is it doing that? Can I dim the camera out? Can I dim the extra cam? Brightness. Let's contrast. No. Saturation. No. Hue. No. Gamma. No. Why in the heck are you on 50 hertz? Let's put you on 60. White balance temperature. Sharpness. Backlight compensation. No. Aperture priority mode. Exposure. No. It's still way too bright. Contrast. No, that doesn't help. Saturation. Just makes me look more darker. Hue. No. Wow. Gamma. Way too bright. And now I'm really blue on that screen. Gain. Zero. Wow. White balance. What about capture manual mode? Sorry guys, I just cannot get this with this camera. BGR3 emulated. What? How about that one? No. That one? No, that just freezes the camera. I think I just lost the camera. Extra cam. I think we're gone. Yes, I think I just lost that one. What happens when you mess with this. I wonder if we'll ever get the camera back. Well, I could get the camera back by resetting it, actually. Properties. There we go. One camera back again. Don't mess with that, William. But it's hard to see. I honestly really wish I had something to diffuse this. Piece of paper, maybe? Do I have... Let's try. Ah, it is still, to me, it's not bright, but to the camera, it is just overwhelming, and I can't do anything about it. I wonder if the face cam is better. I wonder if the Logitech is better. Yeah, it definitely is better than the Chinese camera. So what we are seeing here, you can see it cycling through green and orange at the moment. Now, as it hits every factor of 2, it's moving 1 pixel. So I think I can demonstrate this a little better with by taking the loop completely out for the moment. So if we set this first value as 1, we get a completely 1 green row right there. If we set this to 2, we get the green row moving 1 over. So I've got them all lit. So let's turn off and change this to 1. I'm getting pretty good at the coordinates of this. So 1. So we are in red. And we are in the second column, basically. First row going across, second column going down. But all the others are lit. We don't want that. That was my problem. So if I change this to 4, I move 1 bit over, but we're in reverse of what we want. If I set this to 255, and this one to 255, we still have the red lights on. Now I'm just going to unplug it for a sec to blank it. So this is where I'm kind of stuck. I shouldn't be having the reds on. I should be having that one on, but that's off. It's in reverse of what I thought it would be. So if I go 0 here, all of them are on. So if I go 255 on here, all are off. So I wonder if I have to work backwards. So if I'm at 128, they're all lit except for the last one. If I go to 129, yeah, okay. So 255, let's say last one is 254. There we go. So 254, we have 1 pixel lit. Now this is strange. I wonder why going all the way up to the other end. So 254. So if we imply that, then it should be 252 should move the pixel. Okay, 252 lights 2 pixels. So 254, 250 is factor 4 less. And we move the pixel again over. So -8, 242. And again, we are doing moving. So 242. So we have to figure out. So we know that 254 lit 1. So if we take off 16 off this, is 254, 244, 240, 238. What happens on 238? No, we're still lit on the end with red. Okay, so 254 gets us the end pixel. So what happens when we take the other colors and we do 4? That's still red. Now it's yellow. So I changed green. We need a color chart. I was meaning to do this actually. So let's go up to our web searching here. And we need this one right here. Web colors picker hex. So we need HTML color code. Let's try this. So red, green, blue. So they say here, for example, orange is 255 on the red, 87 on the green, and 51 on the blue. So let's try that out. But I know if I put 255 on that, it might turn off. So 87 and no, not 87. It's since I'm doing red, blue, green, I have to do the middle one as blue. And blue was 51. 51, 87. And I'm going to add another screen into here. Add video source, existing extra cam. Okay. And we'll just lock it. What did I just do? There we go. And we'll lock the extra cam. Okay, so you can see, kind of, here, let me move that. We didn't get that effect. Not the HTML color picker. We end up with green, blue, green, blank, green, blue, blank, blank for our thing. So I'm wondering if we have the numbers backwards. In the sense they're in reverse. So instead of 255, let's put 0. Instead of 51, BC 255 minus 51, 204. Let's do it that way. 204. And the 87 one, let's change it to 255 minus 87 and 168. Let's see what happens. 168. Well, that changed things. Now I have a complete row of red. So change that to 1, 2, 4. So I am moving down the pixels but turning them off. So at 128, 128. Imbalance. Oh, I lost my square bracket. There we go. 27. So I'm still not getting the color adding correctly. It's not correct. So we need to find something better than this. This doesn't work because So So I can move the rows. I can select how many rows. I can move up the column. So, well, that's the other thing. 128. Let's make all these 128. So they're all red. We make them 1. Still all red. 2, Control S. Still all red. 4, 4. 8, 8. Still red. 1, 1, Control S. Zero, Control S. So not only do we walk up the pixels with these, on each color, so the end color right now is not quite red. Go 0 on that. No, it's more of an orange color at the moment. Now we're red. Go back to 127. So we got a whole long row of green. But yet we don't have a thing turned on green. Let me just unplug and reset it. Nope. So I'm kind of stumped on this at the moment. Trying to figure out this bit pattern here. So 64 on the front. That'll just move how many pixels are on. Yeah, so that's back one. $64. 127. 255. See, we're stuck in red. So we know that this turns off a pixel. And we know that 255 we're all green now. So red and blue equal green. So if we're in green and we're at 255 on the color chart here, and we should be yellow. Like in reverse, we're not what we think we are. Well, let's change this middle number to 0, and we'll go to the tail number here, which is supposed to be green. 255. Now we're blue. So I'm wondering if the Arduino does it differently than the Python does it. I wonder if I do actually have red, green, blue. 0. See, that's the problem. I take the first one and make it 0, and now we're all back to red. In theory, I should be blue. 127. Well, on 127, the last pixel is red, and the first 7 pixels are blue. 128. And on 128, the first 7 pixels are red, and the last one's off. 129. 200. 254. 200. So go to 255, and then the other colors start showing up on red. So if we do anything from 0 to 128 on the first bit, we end up with moving the red pixel around. So for our for loop here, I'm just going to change this back. I'm going to go unexpected ident. Yes, I know. What we're going to do is change our range. Instead of ending, we're going to change it to 8, which makes it from 1 to 128 instead of 255. And then we're going to change this first one to bit 1. Okay, we're cycling through the reds. Off by default or on. I wonder if we go like this and say plus 127. Well, now we're doing the other direction. Bit 1 minus 1. I know I'm close to figuring this out, but I'm not 100% sure yet. I wonder if we change that to 128, what happens? Oh, we're out. Our bit is too big. Not good. So our bit is starting at 1. Our loop is starting at 1. So after the red's done, it becomes all green. I have to think more about this. Figure out what's going on. But I'm getting close. I am getting close. So, yeah, it's just too bad that this is... It's this freaking glare. I can turn that light off. Well, there's not bad. We can see that. So that is what I'm at this at the moment. Now I have to sit down and just think, and this will take me hours and hours and hours of doing to figure out what's going on. Plus a bit more research, maybe ask some questions. What I don't understand is why a value of 0 on the red bit, I think is red, That's the other thing too. Let's make this 0. See? And it's constantly just going red. You'd think I would be getting, what about plus 127? Now if I put that at 255, I'm cycling through blue and green. You're wondering, okay. I'm playing with the 3 numbers in here. And I have to find a diffuser. Yeah, you can see it. Cycling blue, then green. And notice the last one is going brighter and brighter and brighter. Now if we change the middle one to 255, now we're doing just green. And if we do this, bit 1 plus 127, as we cycle through, it gets brighter and brighter and changes color. It's like it goes backwards. Take this one off. Go Control S. And we're green and off. We set that to 255. That's green. 255. Whoops. 255. So all of them at 255, we end up with blank. 254, we end up with a very bright green on the end. 252, we end up 2 bright greens. Let's see, 1, 2, 4, so 251. We get the third one. So 8 off the top, 255, 5, 6, 7, 3, 247. Yeah, we move again. And that was 816 off 255 is 245, 240, 239. Yeah, and we are moving 1 pixel at a time. We say 254 on that one. And now we've turned the blue on. If we turn this 254, the end one becomes red. 252, no, 255 minus 2 is 253. So it's still blue on the end. Very dim though. 255 and 251. Yeah, we still have a very dim red at the end. Yeah, this doesn't make sense. Let's see, 239 on the red one. So red on top of green. So red on top of green. In theory, we have red of 239 on the color chart. And green, we have 254, maybe. Yeah, well, it matches. The problem is the pixel's moving on the color. It's almost like eight. Does this mean it only has actually like? No, I've seen it cycle through a lot of colors. Doesn't make sense. Keep the values the same. So 1, 1, 1. 254. Yeah, I'm kind of stumped. This will require thinking about this. But I am a lot farther than I was before. Like, I mean, yeah, I can turn certain things on, but there's no rhyme or reason why I'm doing it. So, makes dealing with those single color ones a lot easier, but I can't figure out why that one corner one is red. Why should be red at 254, 255? Yeah, as soon as they do 255 on the red, the other ones become a cyan green type color, really bright. So the end one, if I go 255 on the color chart, 139, 139. See, it doesn't match the, well, at least it doesn't match the HTML colors. I wonder if there's a chart for RGB colors. RGB LED color combinations. Well, there is a thing for it. Here, I'll do the web console searching. What you need, how it works. Okay, programming Sparkies, da 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 da. Red, green, blue, blah blah blah. Try to change the program with the following. So let's see what happens with 50, 100, 100. 50, 100, 100. See, I should get a color here, but I'm not getting a color. Hmm. What else? I wonder if there's a color chart. No, that's useless. I think this is no different than the HTML color chart. So if we were to go into the middle here and we were to go to the middle here, let's say something like that. So 70 on the red, 142 on the green. Now this is where I'm unsure. 142. I might have to flip these around. 108. Let's see what happens here. See, I'm just turning on so many reds because this is all below 128. This actually doesn't work. One 52, 51, 56. Again, we have the problem with this. This is just may not apply to LEDs, of course. Not calculate LED drive currents. No. Factoring LED specs. Some RGB mixing values plus times target intensity. This is getting a bit mathy, isn't it? Leave that out. I need to look at that one. Honest energy line. That's what else we got here. So what does Arduino's site have to say about this? That's dot star. I don't think this is dot star. I think this is not that type of system. Yeah, so as I said, this is going to take research. Okay. What did we do in our code here? There we go. Somehow we stopped the code. So of course, if I change the first one to 255, we have green and blue. 0. We still have green and blue. See, that's what I don't understand. I should only be turning on one color. What if we go 255 on that one? So that... Well, now we're only green. We say 1. Well, we're definitely green. Now we're moving the pixel about, so 128, 129, bit 1 plus 127. We're definitely playing with green. If you add one value from here, the very first one is blue, brightening as we go through the greens. Yeah, this is weird. Who knows? Might not even get it ever. But I've seen demonstrations of this cycling through its color test patterns. I need to find that website that someone else was doing this and he did color, but it was in Arduino. I need to find that out. The other one I think I'm going to do is go back to the wiki page. Do I have it open on here? Junk. Other. Is it in this one or was it in this one? Did I throw it into Arduino? Wi-Fi, serial, donate, dun, dun, dun. No, not that one. Might have thrown in the Adafruit bookmarks. Let's see, he's doing one he made up with 4 shift registers. Oops, sorry. Here, 4 shift registers. So mixing red and green makes yellow. So in theory, red let's go like this. 0. We do go orange. So if we do 127 here, and we do 127 here, 128. See, all red. This does not make sense. 254. I get an orange, but I don't know why I get an orange. So that was one page I was looking at. And this is the page all about this, but from either running it on the Raspberry Pi or running it on Arduino. So you can see he's doing that. Look, so on Pi, so this is the Pi code. Da da da, red data, blue data, green data. He has an array with zeros in it. That's that timing thing. So up here, that's that stuff right there, the SPI setup. So there's our heart values. So you can see right here, he pumps into the first one. 066 FF 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 7E 0318. So if we were to do this, for example, down here, if we were to do 0x00, 0x FF, X FF, and 0x01. We have a whole row of red. So if we change the next here, J, and I think they're bit shifting here. I think that's what this is. I have to look this up and see. They're shifting the row. So I know that in the next run, it'll be 2, which moves the row. And then I knew that this guy here becomes 66. And I can see the start of the pattern here. So in theory, I should be able to clone this code. I'm not quite comfortable. It'll just take me a while with lots of errors to get this converted. But we're looping through the code, and this does the heart. This is this one right here. Web searching. This one right here. This is the heart. So static heart sign. Static heart sign, da 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 da, wiring, blah blah. There's the thing, da 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 da. Heart beating. So he's cycling through colors here. So he's changing the pattern here. This is a small heart. Matrix off. He wipes the matrix. And he loops through this. So technically, you're not seeing pi in here. I don't know why he's got this. This is the Arduino to light up the 8x8 matrix. So this one's more like I could do, but I'm finding I can send the whole this code right here as one line. Heart small, matrix off. The problem is you're not seeing 1, 2, 3 on here. At least I don't think you are, because these are hearts. I think matrix off. Yeah, so the code, what you're seeing in the examples doesn't even match the code actually. Now they do have one more in here. How to light up with Raspberry Pi Pico. And in this case, they have different shapes here. He's rimmed out the heart. He's got Alien, Alien 2, for example. Right? I need to relook at this one here too. So this page was last edited 17 June 2021. Okay. So that's when I'm going to have to look at some more of this code and see if I can decipher what's going on with the colors. But even here, I mean, he is, for example, data 1. If this alien is blue, or kind of that color, right? I'm not getting that. I can throw 0, 1, 2, 3. I can throw in 1, 2 in the row. So I have 0, 2, 1, 3. So 0. Oh, see, this is different. This is is he doing this in C code or is he doing this in Python code? This looks very Python. For J in range, C dot value, C pin 5 pin dot out, bus equals SPI. This looks very Circuit Python. Although he doesn't state it. From machine import, definitely Circuit Python. Let's do something in here, just for the hell of it. Rename code. Where's my rename? There it is. We are going to rename you code 5. We are going to create code.py. And over here in this guy, Control C, Control V. Now we're going to have some issues upstairs here. We don't have a thing called machine, so we have what's called board. Let's try that out. Import pin and SPI. Okay. So line 1, track the code. We cannot import name pin. So what we need here is from code 5, we need to do the knitting part. So we need basically this code right here. Control C. And over here we need to change this from this. So, and we don't need this. Let's just debug statements. Okay, so. And then. Okay, so these guys here, we don't need. These guys here, Control C, let's put them down here, Control V, just in case. We don't need this crap here anymore, like so. Now we're left with this, battery pin, blah, blah, blah. This is Pico stuff, so we're just going to go like this. Because we've already got our CE, Mozzie, and everything already. So we come down here. So they're doing a byte array, blah, blah, blah. C value 0. Let's just spread this out a little bit. We've got a complaint here. That is just simply like that. Well, that's different so far. What else we got in here? So we've got a complaint about bus. Dot right. No. So this SPI. Sleep is time dot sleep. Undefined variable bus. We still have a bus somewhere. Import. Actually, we do using time now. Okay, so we're grabbing pin from somewhere. Okay, just a sec. C value. Yeah. SPI right. C value 1, time to sleep. C value bus here. This is wrong. So this is SPI. And this guy here is time dot sleep. Okay, we still have a pin value somewhere. Problems. No, let's see. Code 35. Where's that pin value? Okay, we're missing something. CS dot value. Not CE dot value. Why do we have CE? Let's change this to CS. Okay, bool object is not callable. Line 35 still 35 CS value. We're missing something here. Code back here. Okay, got all that. SPI unlock, SPI try lock. True. CS value is true, not 0. True and false. So what do we got over here? What are we trying to do over here? Okay. I don't think we're doing that in, no, we're doing as equals. So, equals. Value must fit in 1 bytes. File code pi line 35. Value must figure in 1 byte. Alien J. 7. Control S. Still 1 bytes. Code 35. Overflow error. Value must fit into 1 bytes. Well, we're walking the thing, so C3 is 1 byte. That's not that, so we should be printing alien 0 first into data 0. Then FF into 1, F to 2, like so. So, okay. What are we missing? Code pi line 35 in module overflow error value must fit into 1 bytes. What are you complaining about? This is line 35. Variable byte array. I need some debug. Print quotes J comma J. Is that right? No, I think it's just J plus. No. I did have it right. J is 0. Okay. And now, print a alien IEN doink, 0, doink. Well, actually, it will be J, comma, alien, doink, J, doink. J is 195. Okay. Overflow error, repair must in 1 bytes. Well, woody do. I am in 1 byte. So where are you getting the message from? And I don't know what the tilde means in front of alien. What happens if I take it off? Oh, that helped. And this is wrong. This is supposed to be CS. CS value is equal false. False. And this is CS value equals true. And this would be CS equals false equals true. CS, Control S. Now we require a lock. So back to here again, and we need SPI try lock. No, actually, I want this block of code. Control C and come back over here. And before we do all this, I wasn't doing that. I was doing this. State is not defined. Okay, just a sec. I think I defined state. Yeah. Control C. Come back over here. Control V. Control S. Okay. We are lighting. Now we're back to fitting into a byte again. Why are we fitting into a byte? This guy here? Well, we need more deadly less time here. Oh, we need more delay. Oh boy, boy. Control S. And there was another timer somewhere. Okay, so we were kind of working. Our time here is too slow, so let's add a 0. Well, you can see here, it's kind of an alien. And it is cycling through colors. But it's going way, way, way too fast. Or it's going way, way too slow. We got that. So we come around to right the first alien, and this is where we have our first problem. Time, sleep, 001. Let's slow this down. And slow this one down. Slow this down. There's another time up there. Where's the other one? Yeah, definitely. 5. So we know 1 is too slow. We know 0.5 maybe. How about 0? 3. So our problem is time 0.0.3. 2. It's just going too fast. 5. 9. 1. Well, this is what we're getting. So we definitely have a time issue here. And it's interesting to note that they consider blue as FF, which is we were having the issue with before determining color. I need to get that debug statement out. We don't need this at the moment. We know that this is working. Whoops. So we're scrolling too slow now. If we change this to 4, 3, 2, 1, 0, 9, 8. We are definitely scrolling way too fast. I wonder if we just took the timer completely out for the moment. Let's try something there. Home. I'll take the timer out there, and we'll take the timer out there. I mean, technically we have an alien, but we're locked in. So their code had it as 001. So you can see a mix of red and blue in here, and it's flicks. You almost need a section in here just to clear between the two. Do a clear. I wonder if I can do that. Yeah, I'll work on it later. But definitely, this is a Python sample for Pico. It should work on anyone. We just have to get. It could be that this is rated 5,000, 500,000. How much have I done? Oh, let's go back here. We need to borrow another chunk of code out of here. It's the section where we configure baud rate and phase and all that other stuff. Control C. And we come back over here. And they are, let's see, polarity 1, phase 1. They are doing that on this thing. Okay, let's put our timer back on this one. And we'll put it at 1 again. Control C, Control D. Yeah, no, it's still. I thought possibly. Well, no, I have more zeros than they do. They have it at 500,000, and I have it at 5 million. Let's change that. Control S. So they're doing baud rate of 500,000, polarity 1, phase 1. And I don't think I. Oh, we do have a bits option. So they're saying 8 bits. Okay, I can do that. Comma bits equals 8. Control S. What else can you put in this thing? Oh, sorry. This is what I'm messing with right here. This. So, object must be locked. Param in baud rate desired clock rate in hertz. The actual clock rate may be higher or lower due to the granularity available clock settings. Check the fixation attribute for the actual clock rate. Param in polarity, the base state of the clock line, 0 or 1. Param in phase, the edge of the clock data is captured. Param in bits, the number of bits per word. Okay, well, I mean, we're still kind of an alien. Kind of screwed up, though. Doesn't look like the alien on the thing. Now, I wonder if I have to do this below this. Just a sec. I might have to move this block. Control C. We might have to go here. See, they're basically doing what I'm doing. I mean, um, theirs is a little prettier on the data thing. This, of course, line doesn't work because these are shift registers and you can't do that. Actually, I'm just going to take this code line out because it's kind of bogus. So, I mean, I do have a section in here. Where is it? We can do this. Control C. This is like a code. This is a LED clearing block. So if we go down here and we go like this, and we need the LED clear definition. which is this guy right here. Control C, and we come back over here, and we go up to here, where we defined a bunch of crap. What did I do? There we go. Control S. So what we're doing here is we're coming along, doing their loop, write their stuff out, we clear, and we could put a time sleep bracket 1 in here. So I'm actually seeing the red scroll through. So 0.001, 0.1, 0.1. Yeah. So something with a pico and its stuff, and this one is slightly different. Yeah, you can't. So there is some sort of alien here. I guess can't really do it well. And in theory, it's supposed to be back to the web searching scene. Should be this, but it's not doing that. Now I could set this up for a pico, like I mean this code here. And I might do that. But for the moment, what time? It's 5:03. I think it's time for some food. So, except for the bit of screw up at the beginning of the recording, that's me just puttering around with this board. So, if you like it, as I said, you can subscribe. I'm not after money or anything like that. That's just, doesn't appeal to me. Not that money doesn't appeal to me. No, it's just I don't feel like going through all the hoopla for monetization of YouTube. Right? So I'm looking for 25 more subscribers. If I can get that, I can maybe customize the channel name. Who knows? I might go up slightly in 0.0001% in ranking or something stupid like that. But this is it. I'll call it now.